Proper footwear will protect you from danger and slipping. Wearing a safety jacket will prevent from any flying chips direct to your skin. Wear gloves to protect your hands. Wear the right gloves for the task. Wearing safety glasses will protect your eyes from flying chips while working.
The first thing first in manufacturing steps is measure the materials. Firstly is the shafts. For the shaft, we use a lathe machine to shape the metal rod. The total length of the shaft is 50 mm. The main diameter is 20 mm and both ends are turned down to 16 mm diameter. Next is the top cover. For the top cover, which is 65 mm in diameter and 6 mm thickness, we use a milling machine to drill the holes. There is a center hole of 20 mm diameter and 3 outer holes of 4 mm. These 3 holes are spaced 120 degrees apart. After that, we use a tapping tool to create and force screw thread in those holes so they can hold the screw tightly. Next is the bottom cover. This bottom plate is also 65 mm in diameter and 6 mm thickness, similar to the top. We again use the milling machines to make all the holes and cut the airflow slots. The center hole is 60 mm and we drill and tap the 3 holes for M4 screws. Next is the turbine blades. The turbine blades are cut from a 6 mm thickness metal plate. Each blade is 50 mm tall and 21 mm wide. To make this, we use a metal cutting saw. Once cut, we use a file or grinder to smooth the edge. Each blade also has a slot at the end of bottom to fit into the groove on the shaft, and we shape that slot manually. We redo the process until we got 3 blades. Next, the dimension of screw. We use standard M4 countersunk stainless steel flat head screws. Each screw has 30 mm long. These screws are used to fasten the top and bottom cover securely after alignment.
Alright, now we go in the turning process where we were using the lathe machine to conduct the process. The most important part of this process is the user safety, so that's why we were using safety goggles since there's metal chips flying towards the user. This process starts with the process of preparing the machine to suit the workpiece requirements process, such as the speed of the machine and the type of tip to chip off the workpiece. In this step, we were required to cut a cylinder mild steel into a 15 and 20 mm diameter and 50 mm in length, with 16 mm of length is the 16 mm of diameter on both ends. As you can see from the video, the process of turning for the cylinder mild steel in process. The next step for turning is to cut the square shape of the workpiece and make it into circular. In this step, the circular dimensions was 55 mm in diameter for both parts. In this process, there is a special handle provided where we could hold the square piece by bolting it at the middle of the hole of the workpiece, where the head holds the workpiece and the tail was held by the chuck of the lathe machine. This process uses slower speed due to the cutting process is difficult for the machine and it could lead to breakdown of the machine.
In this part of the video, we are using milling, which is a process that uses a rotating wheel that moves horizontally and vertically to cut off excess and shape the material. Milling was done to make the swerve for the placement of the blade that was made before.
Kalau keras, jangan paksa. Kalau keras jangan paksa.
Next is the drilling process. The drilling process is a process that uses a drilling bit to produce holes. and this process aims to produce 3 M4 holes and 3 M3 holes. The final product should have 3 holes on both top as well as the bottom workpieces.
Next step is the grinding and polishing of the product. This process is primarily used after welding to clear the weld beads and make the product cleaner. But this process was also used in other steps such as the blades to make it finer. This step requires safety for the eyes and hands using safety goggles and gloves as shown in the video.
Countersink process. For this process, we use drill press. And the steps: first, we mark and drill a diameter of 4 mm hole. Next, use the drill press to create a conical hole. Then, ensure M4 screw sits flush with surface. And lastly, clean the hole from the chips produced. And now I will show you the process.
Okay, ready. Sikit.
Threading process. For this process, we only use tap wrench. The steps is: first, drill a diameter of 3.3 mm hole. Next, clamp the workpiece to the G-clamp securely. Then, insert M4 tab into tab wrench. Turn slowly by hand, keep it straight. After a few turns, turn back slightly to clear chips. Continue until full depth, then remove tab. Lastly, clean the hole and test with M4 screw. And now, I will show you the process.
We go into the next part, which is problems that occurred and solutions. During lathe, the workpiece heats up, whereby the cylinder workpiece changes color from the normal silver steel into dark blue color. This indicates the workpiece heats up due to friction. And the solution is to increase the speed of the lathe machine so that it would not only cut faster, but it will decrease the risk of the metal heating up. The next one is small misalignment of the drain during milling. This is due to the inaccurate measurements during the initial markings, where it causes the blade to not fit well between those two workpieces. And the solution was to thin the blade until it fits only in the available aligned drain as shown in the picture. Next one is tapping on the wrong workpiece. This is the cause of a human error, whereby the workpiece, which is supposed to be a countersink part, has become the tap part. So the solution is to continue with the process, but the countersink for the screw head would be on the other workpiece. The next one is the imperfection of welding. This is due to the weld using high-powered and thick electrode, which causes the workpiece to melt instead of filling up the drill holes to connect both the blade and the workpiece. The solution is to lower the power supply for the weld and use a thinner welding rods so that it would not burn through the mild steel in this process. The next one is excess material on the blade, whereby when cutting the blade there is excess material on it, whereby if you do another cutting it would actually cut more than it's supposed to. So the solution is to grind or file the excess workpiece. Most preferably we grind that part since it is much faster and easier.
Finally, we have discussion. For the first discussion, we will talk about planning. Every project should have a proper planning laid out to ensure the project meets the requirement as well as smoothness during the manufacturing process. Next is the marking and measurement. Every measurement and marking could cause major or minor differences, thus making this process a very crucial process in manufacturing the product, as very little mistake could stake the entire project. Next, we have tools. Proper selection and regular maintenance of cutting tools such as milling bits and drills are essential to minimize tool wear and ensure good surface finish. It is crucial to inspect tools before use and replace them when signs of dullness or damage appear. For the final discussion, we have safety. In every laboratory or workshop, there is one main rule, which is safety first, no matter where it is. Thus, wearing PPE is a must in every process, even though it is a minor operation. It is still crucial to take importance in safety to avoid minor or even major accidents that could occur during operations.